Boys, girls, how we going? Doing a video here about one of the reasons I hate Blackstars. I keep saying I'm going to stop taking them, but I keep taking them. So I guess I'm the only one to blame. Here we have this monster. Just have a look here. So it's a Gus something or other. I don't know who he is. Probably some gent kind of guy. I should know who he is, but I don't. 200 watt Blackfire. Fucking 200 watt valve amp. As if that wasn't stupid enough. Alright, so it's got, what, 4 channels? It's got clean, fire, crunch and fury. And then it, because you got 200 watts, they've got a scaling switch knob which apparently takes it down to 20 watts. I don't know if that's just an attenuator, or I doubt it would actually change the plate voltage or anything dramatic like that, because that would require actual engineering, which these guys aren't too crash hot at. Oh fucking, I'm gonna crush my laptop. Oh, my fingers. Look at the size of the transformer. Yeah, it's kind of hard to make out on the screen, but there's my hand. There's the transformer. It's fucking massive. Let's see my sunnies. Yeah, it's about as big as my head. Probably about as heavy. So that's the power one, and then look at the size of the output one. So you could use this thing for bass, no worries. It's the amount of bottom end it would have with that tranny. It'd be ridiculous. And it's got 4, count them, 4 KT88s, which is a bit of a monster of a tube to start with. And it's got 5 of these Hoosers, 12AX7s. Now, this came in a while back, and this is where I'm going to start my rant. It came in with burned grid stoppers on, I think it was that valve, and I think that one. And I found that one of the valves was shorted and was causing a dead short. From grid to either the screen grid or the plate, probably the screen grid, because it's right next to the control grid where the grid stopper is connected to. And I just replaced the tubes, replaced the burnt resistors, one of which was still reading right, but it had shown that it had burnt, so changed it and tested it for ages, couple of hours, and it was good. And then it came back, what, that was about 2 months ago, 3 months ago, maybe not, maybe like a month or and a bit. This time of year, time's distorted. Oh jeez, that's fucking hell, I didn't have my wheat bix either. So it came back with the usual, you looked at it last thing. Which is why I don't like Messrs and Blackstars, because they're inherently badly designed, and when you take the job, it doesn't matter how much time fucking passes, it could be 2 years, they just remember you're the last guy that looked at it, so you must have fucked it up. So in this, I had a quick look, I looked at it literally, I felt like a fucking superhero. I looked at it for 5 minutes and I found, or not even 5 seconds, and I found the problem. So the first thing I was going to do, which is probably first thing you should do if you're troubleshooting, is attach up a couple of multimeters. You've got to have a few of them, and monitor various voltages or currents, or both, while you fired it up. See if anything changes, because the report was it would work for 20 minutes and then cut out or slowly die in volume. So I'm thinking if it's slowly dying in volume, that's a hint. That means that a cap is probably either discharging and the connection to the cap has died, or intermittent and the cap's slowly discharging, and then when it finishes discharging the signal dies. The other thing that could have an inertia involved is the heater supply giving out. So if the heater supply gives out, the heaters are still hot, and it might take them 10 seconds or so to cool down to the point where they can't emit electrons, and your signal will go through that same decline slowly, instead of just cutting out or cutting in and out. It would slowly fade to zero volume. So that's 2 hints. In this case, the first thing I did was I was going to connect all my multimeters up. I've got a few of them here just because I like them. It's a problem I've got. I was going to connect one up to the plate voltage, which is like there. Now I've discharged this. I'll show you anyway. It's good to get in the habit of just always checking, because the one time you go, oh, I've already checked it, you'll forget that you've plugged it in for a second. So you find the cathode, which is there, pin 8, and then find the plate. Now they're pretty smart here. This is one of the things I do like, which more amp manufacturers should do, particularly, sorry, I've got a multimeter in my mouth, particularly on really high power and high voltage amps like this. This runs around 700 and something volts on the plates, and you can't see it on the camera. Instead of mounting the plate supply on the circuit board, they've drilled a hole where the pad should be and connected it directly to the pin on the socket. So that wire makes no contact with the circuit board material, which under 750 odd volts could break down and start conducting, especially if you had a bit of heat, which is a problem on a lot of other amps like the Marshall TSL series, particularly the combos where the valves are upside down and the heat from the valve comes up and heats up the board. So anyway, where was I? Yeah, so that's the plate connection. One of those days. So I'm checking from the cathode to the plate, and we've got, it's upside down. Cathode to the plate, got nothing. So I'll check from ground. There's a ground point to the plate, we got nothing. Check from the actual chassis, which is out of camera, and we got nothing, 0.001 of a volt. Check the other side as well. Let's check a few spots. Sometimes you can even check the metal on a cap. So that's got minus 0.7, slowly discharging with the multimeter. So that's probably on the, that's negative, who knows. Yeah, just check around a few spots. You can have nothing on the heaters, although this does have DC heaters, it doesn't for the output valves. The output valves is a dangerous area, so it's preamp too. So check some of the preamp pins. Pin 1 and 6 on the 12AX7s is the plate supply. They're all dead. Yeah, it can't hurt to check every time. Anyway, now we've done the fucking nanny state bullshit. Let's get to it. So, the first thing I wanted to monitor was the dissipation of the output valves, because that can be the first thing that can make a good day a bad day. If they're over dissipating, you can destroy them. These aren't cheap. These are like, for a full set of these valves, it was like $350. And that was just the power valves, not a full set. Match quarter KT88s ain't cheap. So, the way that this particular amp allows you to check that is they've got a little connector down here, connector 1, probably because they know how important it is, they've called it number 1. And that's hidden away behind all these connections here. see down there, connector 1. So that's it there. Now that goes across a resistor that paths from one pin to the other, and the resistor, let's check its value. The resistor is down here. That's the resistor there, R33, and that's a 1 ohm resistor. It looks like a 1 watt, maybe 2 watt, probably 1%. And that's not a 1%, it would be silver, that's 5%, it's gold. So that bridges the path from the cathodes of all the tubes to ground. They're all connected up to that one resistor, and that one resistor gives a path to ground. Now the cathodes is what is connected up, so all the current trying to find its way from the cathode to ground from all of these tubes. You can see the connection there. They're all paralleled up. They're all passing through that one resistor to ground. So if we monitor the voltage drop on that resistor, we can figure out how much power all of these valves are dissipating all at once. It doesn't tell you individually, it tells you the average over all of them. So connecting up to that, I don't have the proper connector. That's probably something Blackstar has for their testing before they export the amp or whatever. We should read about 1 ohm, and we got 1.3. So that's probably a bit of lead resistance in there as well. So the first thing I noticed when I hooked that up to test it, I always test what resistance it is, because that allows me to calculate later the current draw of all the output tubes. So first I was getting like 10 meg. I'm like, well, that's wrong. So I suspected that maybe it had blown that resistor, fused it. But then when I went to remove the leads, it popped up to like 1 ohm again, and I was thinking, hang on, was that my leads playing up? So I did the old jiggle, and couldn't get it to do it again, so I went to remove them again, and hey, look at that. Whoop, it went up to about half a K there for a minute. 2.4. So it's this connector here. Jiggle it around. It goes to open line, it goes to 1.4. Oh well, it goes to 1 meg. 10 ohm. So this has nothing to do with the previous repair I did. It was a shorted tube, one of these resistors, one of those resistors, well, two of them. One was discoloured, one was fused open. I fixed that, replaced the valves, and I fixed the problem. Now secondary problems come along because of fucking connector city over here. Because it's just too complicated an amp. Like, I've never seen an amp that can do everything that's this complex, that's reliable. It's as simple as that. Right. So, like I'm showing you, the resistance is varying dramatically there, and what that'll do is it'll change the amount of power that tube is able to dissipate. If that's a real unreliable connection, probably as it's heating up, it's doing something to the connector. It's expanding its contacts or something, and it's dying after the amp's starting to heat up a bit. So I could try and clean them. I can see there's a bit of corrosion on the connector. Probably going to be a bit hard to make out, but That's the connector there. Poor little thing can't focus. Yeah, so you can see a few little dark spots on it. The other one's probably just as bad on the other end of the cable. Little dark spots down there, that's a bit of corrosion. It looks like they're silver plated, but silver still tarnishes. So I might give them a clean up. I don't really want to solder anything, hardwire anything to anything, because these boards are such a bitch to remove. And then I might break something else in the process, which wouldn't be fun. Because these things are house of cards amps. They only just work when they're built. But yeah, my whinge is basically I touched this amp, so now I'm going to be responsible for everything that goes wrong with it. It's not a whinge at anyone, the customer or anything, it's just this industry. It's jumping up and down there in resistance. Now, if I fix this and anything else goes wrong, it'll come back again. And because it's been away for like a month or two between the last thing going wrong and this one going wrong, the chances of it having some other catastrophic failure is getting higher and higher with every day that someone owns it, that it's not in a landfill. These caps, Nova, they're not a brand you can buy, which happens a lot with these amps too. Anything made in China, you get these caps that you can't buy from anywhere. And it's not because they're great, it's because they're shit. No one wants to sell them because they're liable for them. These guys are happy to put them in their amps. I've seen a lot of them that have exploded after very short periods of time. And there's like probably 50 of them in this amp, so that chance is pretty up there because the thing's so complex and has DC heaters and all sorts of switching shit. There's just too much going on in this amp for it to be reliable. If you buy something with that many knobs, it's not going to last. I hate to tell you. Find your sound, buy your amp to your sound, but if you're going to have a Swiss Army amp, you're probably better off going the modelling route, really, because at least then it's just a DSP chip and a couple of analog to digital, digital to analog converters. Goes wrong, you throw it in the bin. These things, there's so much money in them, in that transformer, the tubes, and there's just so much to go wrong, so much high energy inside this thing, and yeah, I guess if anything else goes wrong in it, I'm going to have to figure that out too. But I've heard through the grapevine that Blackstars aren't going to be around a lot longer, at least not in their current form. So all of these amps are going to come in for repair. I'm not going to be able to get bits. That's assuming I could even get bits at the moment. I probably can't. They probably want to send it to their super special repair guy that they've basically cut to the bone until he can't afford to fucking eat, which is how these companies operate. Anyway, I'll stop whinging. I'll clean that connector, see how she goes, put it on a test for a couple of hours, I guess. It's not going to be fun in this heat, having 200 watt tubes and 200 watt amps heating up the workshop, but it's going to be 35, 36 degrees here today anyway. The storms are already building up on the horizon. So, yeah. Anyway, I'll stop bothering you. Don't bring me any more fucking Blackstars. They fucking suck. Have a good day.